On the circle, so there are auxiliary elements of the circle. Okay, again, the center and the radius is pretty obvious for most of us. But when we call the auxiliary elements, we call that if I pick any 2 points on the circle and connect these to 2 different points, that we call that a chord. And diameter is the longest chord because obviously it covers 2 points on the center. Okay. And diameter, then we can say that it is twice the radius. Okay. So we call this line CD is the diameter, AB is a chord. CD is also a chord, but it is a special one. It is called the diameter. The other auxiliary elements we call as the tangent. Again, it is one of the most important parts on the circles. When we say the tangent, it means that a line is intersecting a circle exactly at one point. And this intersection is called the tangents of tangents. And again, tangent line, for example, if I pick a point here, if I draw this here, it's a tangent line. Pick a point here, draw it here, it's tangent. This tangent is going to become important because when we draw the radius from the center, when we draw the radius, so again, center to the tangent point, it is always perpendicular. That is going to be important because the circle questions can be solved using either similarity or the Pythagorean theorem. Similarity is beyond the, we are not covering similarity in this part here, but we are definitely we are familiar with the Pythagorean theorem. Okay. Now, again, chord, diameter, tangent, this is the radius. Now, the one that we did not cover is the line secant. Secant is a line that intersects a circle at 2 different points. So you can see that, well, what is the difference between the chord and the secant? Chord is this line segment, right? Secant is this line that goes forever. Okay. And it is important to remember this vocabulary as we will be using this quite a bit throughout this class. Okay, let's take a look at this example together. The example here, we are given a bunch of lines and line segments. We are asked to name all the diameter, chords, secant, tangents on this over here. Okay. So we can start with, let's say, OB here. Okay. Let's go with alphabetical order. So let's go with OB. Now, we know that O is the center, B is any point on the circle. So therefore, OB is going to be radius. And again, because today I'm not familiar with who is the parent, like what are the parents and the students here. So it is hard for me to involve everyone here, okay? But for those who are students are joining us, you are more than welcome to answer. You can unmute yourself and answer. So we covered the OB. The next one on the line is OC. Okay? And OC is going to be, again, O is the center, C is a point on the circle. Then OC is going to be also a radius here. Again, OD is not drawn, so I'm not into OE is not drawn. Let's look at OF, which is also the radius again. Okay. And then now we are done with all the ones that covers OB, OC, and so on. The other one we did not cover, so let's start. For example, we have the line GH here. So let's start with those lines. Now GH, we can see that the line GH touches the circle only at one point, which is point A. So therefore, GH is our tangent line. And then we know that so we covered the GH. Now look at CF. We go from bottom to top. CF passes through the center and it connects 2 points on the circle. Therefore, it is a diameter. The only thing that we did not cover is ED. And I'm also going to look at line L, don't worry about that. ED is this line segment here, so we call that a chord. But the line L which is this line here, that intersect with the circle at 2 different points. This is our secant line. Okay. Now, the chord is a line segment that connects 2 different points on a circle. Now, notice that, like I said, if I draw the radius, right, it is going to be the perpendicular bisector of this chord. And you can, because you can also see that here is an isosceles triangle, right? Because OA and OB are both radius. Okay. So if you draw altitudes, OH, then we know that it's going to bisect the base. It's the property of the isosceles triangle. Okay. Next page. So I'm going to skip this part. Again, this one we'll cover it with students. Then we ask them to name LQ. We'll give, I will give them 2 minutes or 3 minutes. Then we go over these together. Okay. The idea of this analysis will be covered the angle, secant, and so on. Now let's talk about the angles here. We know that the angle that's whose vertex is at the center is called the central angle. So AOB is our central angle. So is COB or COA, all central angles. Now, the central angles, the arc that it covers, BC. So the arcs can be measured in 2 ways, either with a degree, with angle, or we can find the length. In this case, we're interested in finding the angles. So the arc across from the central angle is equal to that angle. So if we say that angle BOC is equal to angle A, therefore arc BC, angle BOC is going to be equal to arc measure of BC, which is same as A. Similar here. If this is X, then here is going to be X as well. Okay. Now, in the example here, during the in-class exercises, we go over the questions together. So I give them some time and then they share answers. But it is more important to see how they approach to that answer. Obviously, this is only one line answer question. So we ask them, the question is find arc or length of ST, RS, and SRT. Okay, so SRT is given, SQ, this angle. I think there is a stick here. So they are given, picture that is correct, angle SRT. Sorry about that. Now, so we're asked to find this angle here as well. First, let's start with angle ST. Now, Q is the center. It's given in the problem. And that means SQT is our central angle. So that means arc ST is going to be same as SQT, which is 122 degrees. Now, arc RS. So you can see that RT is diameter. If RT is the diameter, then we can say that this part here is half of the circle. So the half of the circle is equal to what degree? The whole circle is 360. Then half of the circle would be 180. So therefore, arc RS will be 180 minus arc ST, which is 180 minus 122, it is 58. Now, this is a little bit more challenging. So the question is asking for SRT. You can say that, well, this is not the central angle. And right now we have not learned how to find the angle when our vertex is on the center, right? I mean, is on the circle. But notice that we don't need to use that because we know that QS is a radius, right? We can say that QS is our radius. QR is also the radius. So therefore, SQR is an isosceles triangle. So to find the angle in an isosceles triangle, to find these equal angles, I need to find the vertex angle. And we can do that because we found that RS is going to be 58, right? So therefore, we can see that this is also 58, right? we can also find it 180 minus 122. So we can say that angle SRT is equal to 180 minus angle SQR divided by 2. So it is 180 minus 58 divided by 2. This is 90 minus 29, which is equal to 61. Okay. We have no questions, we're going to move on. So again, like I said, I will skip some of the problems here. We're going to find environmental work on number 4. So if we have I is the center, given that GIF is 103 degrees here, right? So this is also 103 degrees, right? Because because I is the center, okay? And that means GIF is a central angle. It is equal to the arc GF. And then it is given that arc HD is 15 degrees. And then arc EID is 18x minus 2. The question is find x. Now I apologize. So we can say that, well, I don't know this angle here. If I knew this angle, then I would be done because DIE is a central angle. So therefore, it is equal to 18x minus 2. We don't know these angles. Okay. But in the previous chapter, we learned that the GIF and then HIE are equal because of vertical angles. Okay. So GIF is equal to angle HIE, and therefore it is equal to 103 degrees. Okay. Okay, again, vertical angles. Now we know that we know the HIE, right? It covers this whole arc here. Okay. So we know that angle HIE is equal to the minor arc or the smaller arc of arc HE. So 103 is equal to 18x minus 2 plus 15. So 18x is going to be equal to 90. Therefore, x is equal to 5. Okay, so this was the angles part. Again, I will skip these ones. Okay. Now, let's look at, so we covered the central angle. The other angles we need to figure out is, we are going to talk about, is called the inscribed angle. And the measure of an inscribed angle is 1/2 of the measure of the arc in the intersect. So what do we mean by inscribed angle? Let's say we have a circle. Now, instead of being on the center, I can pick a vertex that is on the circle. Okay. So these 2 points, A, B, C, they're all on the circle. So the angle here, ABC, is called the inscribed angle. And the inscribed angle is 1/2 of the angle arc there is across from it. Okay. So we know that angle ABC is equal to arc AC divided by 2. But the cool thing about the inscribed angle is the other, like for example, I can draw another inscribed angle that is across from arc AC. And if I call this point D, we can see that because it is across from the same arc AC, that means ABC and then ADC are exactly the same. Okay. So it doesn't matter how many I draw here. Okay. For example, this is also the same. We can draw another one. Okay. So let's say something like this. Here is also the same, right? Again, these are all, because they're all across from the same arc. Okay. So if arc AC is, let's say, 100 degrees, then all these are 50, 50, 50. Okay. Now, we look at the questions together. So in here, it is CBA is given as 50, so therefore AC, and you can see that it is on the circle. It is not on the center. So therefore, x is 2 times ABC, which is 100. Over here, x is 120 over 2, which is 60. Again, it is inscribed. And over here, now let's take a look at here. We know that CBA is across from arc AC, but we do not know what AC is now. But pay attention that we have another angle that is drawn, which is COA. And CO is the center of the circle. Okay, and although it doesn't specify here, the teacher will specify O is on the center. O is the center in all this. Okay, so COA is a central angle. So that means arc AC is equal to COA, which is 90 degrees. Then CBA is going to be 90 divided by 2, which is 45 degrees. Okay. Again, I'm going to skip these examples, so we're going to take a look at these ones here. Okay. Now, this is a little bit more challenging. It is given that APB is 2x, ACD is x, and then arc BC is also x. These are all angles, by the way. Okay. The question is, what is the arc measure of BX? Okay. Now, let's use what we know, what we learn, right? First of all, neither of these points are centers. So there's no central angle here. And we don't know if these are diameter or not. Okay. But now, let's see that, but we know that BC is a arc of BC is x, but that and that arc is across from BDC here, right? So again, angle BDC is half of arc BC. So therefore, here is x over 2. Now, then we are pretty much done. The reason is so we know that x over 2x, so I can find this angle in terms of x. We know that angle DPC is 180 minus x over 2 plus x, right? But because of the vertical angle, angle DPC is also equal to angle APB, which is 2x. So now we know that these two are equal. So 180 minus x over 2 plus x is equal to 2x. So we know that 180 is equal to 2x plus 3x over 2. So 180 is going to be equal to 7x over 2 here. So x is equal to 360 over 7. Number 11 is, we put this because this is a very important concept. The question is, what is the value of x? Now, you might think that nothing else is given, but notice that ABC is a inscribed angle, excuse me, and it is across from arc AC. So we know that then angle ABC is equal to 180 divided by 2, which is 90. So we can say from here that now every time we see an angle across from the diameter, right? So B, remember, of course, B has to be on the circle. This is equal to 90 degrees because of the reasoning here. Then later on, when the level one, later on, then we go over that when you draw line BO. So in any right triangle, you know that median is equal to half of the hypotenuse. And the reasoning is radius, radius, radius. This is a very important property, okay? And the reasoning is this. Okay. I hope you're good so far. Okay. I'm gonna move on. Now, so we covered the central angle. We covered the inscribed angle. Now we did not cover when I had two chords intersect inside the circle, or I have two secants or two chords extended, so these secants intersect at point X. What are the angles going to be? Now, if I have two chords intersect inside, the angle, okay, let's call this angle X. Then we get that angle X is equal to arc AB, the measure of arc AB, plus the measure of arc CD divided by 2. So we are taking the average of these two arcs. Again, the chords are intersecting inside the circle. If this sequence, this AX is a secant, BX is a, or AD is a chord, BC is a chord, we extended it, intersected a point X. This time, it is equal to the difference of those. So angle, let's call this angle X again. Angle X is equal to AB minus CD divided by 2. Again, we take the average here. In this one, we take the difference. And we already covered figure 1 and figure 3. And we go over the in-class exercises. For instance, let's look at number 2 here. We are given that arc VT is at 75 degrees and VUT is 40 degrees. The question is asking for SW. Now we know that the chords intersect outside the circle at a point U. Therefore, we can apply the formula right away. We know that angle TUV is equal to angle WS plus arc WS plus the arc angle TV, minus, divided by 2. It is given that TUV is 40, WS is something that's what we are looking for, minus 75 divided by 2. To solve this, we multiply both sides by 2, and then add 75 to both sides. So 80 plus 75 is 154. Okay. Again, during the class, it is a lot more interactive. We ask the students, or we have a, again, like I said, we have either a poll question or a Kahoot, but we try to involve them as much as possible. At the end of the day, for the online courses, please remember that, again, no matter how much we try, it still depends on the students, right, to participate. So, but like I said, we call name by name and we ask them to participate. Don't care if the answer is incorrect or not at that point. And then if it is incorrect, we try to figure out why, where the mistake was. Okay. But we try to encourage students to attempt solve these questions and to share their solutions or the answers. And again, I'm going to skip this. So let's solve number 4. Again, this is just to give you an idea of level of the questions. And for number 4, we have a circle O, meaning that the center is O. AB is a chord, ED is a chord, BE is a, and then BE is a chord. The secants are AC and DE intersect at point X. And then ABE is an angle of 35. And then AXE is an angle of 15. The question is, find the measure of CD. Now we can find the measure of CD. So let's see. The question is asked for CD, right? To see what we can do, to see what else we need to find this degree measure. Now notice that these two secants intersect at a point X. So we know the formula for that. We know that angle AXE is equal to arc AE, because this is covered, right? Arc AE measure minus arc CD measure divided by 2. So we know that AXE is 15. We don't know AE, right? Minus CD over 2. Because we are asked to find CD, that means we know AE at some point, right? So the goal is find AE. Now we know that AE, if you take a look at here, is across from this angle, which we just used, but it is also across from the angle ABE. And we know that ABE is an inscribed angle. Therefore, arc AE is 2 times arc ABE, which is angle ABE. 2 times 35, which is 70. So we get that 15 is equal to 70 minus CD over 2. So we know that CD is going to be equal to 40. And the questions goes from like 1 step to 2 step and so on. So we have questions. There are the very first few, like 99% of the students can answer it. And the middle questions maybe half. The later ones, we have very few who can answer those questions. Even if they answer correctly at that time, then in the next topic, then they may not be able to. So it depends. But most of the time, they cannot answer the harder ones, which we try to help them. So for the harder questions, we break down into smaller cases. Okay, so again, I'm skipping these. Then we talk about the area. So we talked about the terminology, angles, now the area. And at this level, students already know what we mean by pi, what is the circumference, and what is the area. So, okay. And so let's take a look at an example here. Find the ratio of the circumference of a circle with radius 1.125 to the circumference of a circle with diameter 2.25. Now, we know that, again, the question is circle with radius, so we know that circumference of a circle is 2 pi r, right? So if you write the ratio, it's 2 pi times 1.125 divided by circumference of a circle with diameter 2.25. So we know that 2 times the radius is diameter. So I can just say pi times 2.25. And what is the ratio going to be here? Pi will cancel. We know that 2 times 1.125 is 2.25. So the answer would simply be 1. The question is asking for 8 to 8. It's just basically 1. Okay. Remember we talked about that we have the arc length. We can measure arc 2 ways, a degree measure and the length measure. And this is why we also need to learn about angles, because to find the length of an arc, we need that angle. So remember, this is a ratio part, right? This is because the whole circle, which is 360 degrees, is the measure of this whole circle is the perimeter, right? So we know that it is, and it covers 360 degrees. So we can find the ratio is alpha to 360. Again, I'm just looking at this region, not the whole one. The whole one is 360, right? Is equal to the measure of arc AB divided by circumference, okay, which is 2 pi r. So that means AB would have a length of pi over 360. I'm sorry, alpha over 360 times 2 pi r. Okay. Now, again, in here we find the length of each arc. So the question is asking the arc of this HG, right? So we know that HG is equal to, again, this is 210 degrees. That means the central angle here is also 210. Let me write it a little bit over towards here. So HG is 210 over 360 times 2 times pi times 18. This one here is 20. So that means HG is going to be equal to 21 pi. We don't ask them to multiply with pi. We just leave it in terms of pi, unless the question specifically is asking for. So here is another, for example, there's this Pac-Man game here. The question is asking, what is the perimeter of the monster? Right? So most students, they can find this, but they forgot to add the radius. Okay. Now we also talk about the area. So the area of a circle is pi times square of the radius, right? So to do this, we can divide the circle into, let's say here, 16 equal parts, and then you can see that this is the circumference and this is the height. What happens is, if we increase the number of equal parts, then the area of the circle get closer to the area of a parallelogram. So that's how we get the pi r squared. Okay. And then we talk about the area of a sector. Area of a sector means this region here. Again, the whole circle is 360 degrees. So when we find the area, it is pi r squared times 360 over 360. But this one here is going to be, let's say, A over 360 times pi r squared. Again, because of the time being, I'm not going into details. You might feel it's a little bit faster. It's just because of the time limit today. Okay. And then we cover the shaded part area with students, or we call it funky areas. Say this, and then some questions like in this form, and then so on. Okay. For example, let's go over this problem here. We have the logo of the company painted. There's a 10 centimeter radius, right? Here is 10, here is 10. And then these are perpendicular to one another. Okay. The question is, what is the area of the shaded region? Now, these are perpendicular, right? Okay. Because these are perpendicular, we can say that this passes through the center of the circle. Okay. Now, then that means here is again 90 degrees, right? Then we know that here is 10, here is also 10, right? And then only for the shaded area, we need 2 semicircle plus this part of a circle. Okay. Again, 2 semicircles plus 2 times this part of a circle. Now we know that the semicircle, the diameter is 10, so the radius is 5, right? So it is 2 times semicircle makes it a whole circle. So it is pi times 5 squared. And this one, because it's a 90 degree, we know that it is quarter of a circle. Because it's the quarter, then we know that it is 1/4 of the whole circle, but I have 2 of them, right? So I multiply by 2. So 2 of the quarter makes the semicircle, or you can simply find that it is pi times 100 or 10 squared divided by 4. Again, divided by 4 comes from, because it's 90 degrees, this quarter of a circle. So we have 25 pi plus 50 pi, which is 75 pi. Okay, so I'm going to stop here, and then I will take any, again, this is like a sample handout. Okay. We go, but you might say it is 24 pages, but like, please remember, this is intended for a 3-hour session. Okay, and again, thank you so much for listening to the class. I will go over the I'll go over the momentum classes, and I will take questions in the meantime. To find our classes or to find more about momentum learning, you can go to our website, momentumlearning.org, and then if you click on registration, there's a contest math curriculum where you will be able to see what we will be covered in our camps, on our camps. So here's our structured contest math curriculum. Students usually start with contest math 100, which is for grades 3rd through 4th or an advanced second graders. And then while we go, so when the student reaches 200, they might take the intro class, depending on their level, or depending on, we offer tests. And we also look at the teacher recommendation and how they perform in the CM200. And then 201 students can enroll in intro without needing an approval. And so again, it requires also the completion of algebra. If you have not taken any of these classes from us, then I would recommend to take the test and see if it is the right level. Students who are done, so they continue with 301, 401, and they move on to either 500 and 541 and so on. Okay. So as you can see, the prerequisites here, This is also available on our website. How to choose the right level for the students? Again, for introduction to contest math, assumes that student completed is very comfortable with pre-algebra, and or they completed 200. And we covered the level of is similar to school level math counts and an AMC 8 questions. Here's our online program. So again, this is the introduction to contest math. The first session is Algebra 1 geometry. The second session is geometry, and the third one is number theory and combinatorics. During our online classes, so everything is recorded. It will be available to you by the end of the day. Students will, during the summer, we do not assign them homework, or if we assign one, it will not exceed 3 problems. So it's like somewhere from 1 to 3 problems. If there are certain topics that is not covered in the previous day due to the class level or due to again, like how fast the student can cover, or if he gets too many questions from students. So the pace may not be very strict, but we do cover them the next day. Again, as you can see that we start with algebra, so it is really important students are familiar with pre-algebra. I mean, I'm actually mastered pre-algebra. And see here again, the handouts will be available via PDF, and that's pretty much it. For the online courses, you will get an access to our Canvas learning system, where you can download the class material or listen to the class recording. The class is 3 hours, but we give a break at the end of each hour. We good? If you have any questions, you're more than welcome to shoot us an email or at info@momentumlearning.org. If you have questions specifically for me, then this is my email address.